what we have here is a rational function. Now, as x tends to 2, let's just plug that in and see what we got. Now, as x tends to 2, we are going to have, plugging 2 in place of x here, that will be 2 times 2, that will be 4. Then 4 minus 4, that gives us 0, right? And then we substitute 2 in the denominator, 2 squared, that's going to be 4, plus 2, right? That's going to be 6. Then 6 minus 6, that's still going to be 0. Well, in limits, or in calculus in general, whenever we have this kind of fraction, 0 over 0, right? The numerator is 0 and the denominator is 0. That is an indeterminate form. So that is indeterminate. Indeterminate. Right? And when we have such, right, there are many of them, but this is just one of them, 0 over 0. So we have an indeterminate form. We do not just end there, right? This is not allowed. So we need to do more work, right, in order to bring out a result. Had it been we had only 0 in the denominator, the numerator was a non-zero number, then we will just end there and say that the limit doesn't exist because you cannot divide by 0. But in this case, the top and the bottom, they are both zeros. So that's an indeterminate form and we need to do more work. And the more work is to factorize any of this or the both of them if we have to factorize the both of them. Okay, so let's see. The numerator is a linear function, so we can't factor that, right? We can't get the factors of a linear function. Instead, we will do for the denominator because that's just a quadratic. Good. Okay, so let's see how we can factorize the denominator. That's a quadratic equation. So by just factoring that, we're going to have the limit as x tends to 2. Now let me put down the top. Now the bottom, we need to get the factors of x squared plus x minus 6. Well, we can get the factors of this by seeking two numbers whose product will give us this times this, right? That is the product of 1. No, the coefficient here is 1. Seek two numbers whose product will give us the product of 1 and negative 6, right? Good. And whose sum will give us positive 1, which is the coefficient of the x there at the middle term. Good. But running around with those things, we're going to have the factors to be x minus 2 and then x plus 3. Great. Okay. So we factorize the denominator. Maybe let me factorize the numerator because that's possible. But in this case, it's not just factorizing. We are just going to take out something that is common, alright? So in this case, we have a 2x here, we have a 4 here. 2 is common in those two terms. So if I take out a 2, I will change this 4 to 2, right? So as to complete the product. So if you multiply this backwardly, you get back the numerator which you had. Okay, so in this case, we see that this factor and this factor are the same, right? We can cancel that. We can cancel that because we notice that x is not equal to 2. Now, from the definition, when we started limit, I gave a definition of limit, we talked about a function being defined in a domain. Now, if we have a certain point, let's say 2, in that domain of definition of the function, then the function is said to be the limit of that function, okay, adapt as the input tends to that point, right? Good. Does not mean that we are talking about that point exactly. We are only talking about the value of the function as our input gets closer to that point, not actually that point itself. So as we are getting closer to 2, we are not at 2, okay? So we are saying here x is not equal to 2. Since x is not equal to 2, that means that x minus 2 cannot be 0. And that means then that we can cancel common factors, right? And then that will reduce our fraction to limit as x tends to 2 of 2 divided by x plus 3, right? Good. And then from here we can now substitute, alright, and test. So we do the substitution now. So as x tends to 2, we just substitute to see if it's still going to give us an indeterminate form. So when we substitute, we're going to have 2 over, so as x tends to 2, that will be 2 plus 3, which is just 5. Well, this is a real number, 2 over 5. So that real number is then called the limit of that function. Great. Okay, that was for the first question. Okay, let's go over and check how we will do with the second question.